So we had studied about this thing in the last class. I had discussed that why do we need basically linear algebra, because we are working with large size data sets, and we have to deal with, while dealing with the data sets, we need some kind of data structure, some kind of representations, so that we can do some kind of operations over there. And here we say whenever we have 1D data, we represent that data in the form of vectors, and whenever we have data with more than one dimension, we represent their data in the form of a matrix. So we are discussing about the various vectors and the operations of the vectors. And when we are dealing with the matrices, so we talk about the matrices and the various operations that can be performed over the matrices. So we should have basic understanding of what can be done with the vectors and what can be done with the matrices. So what are the prerequisites, and what for the vector operations, and what are the prerequisites for any kind of matrix operations? Can you tell me, when we have to do the matrix multiplication, what is the prerequisite? Any one of you?
Columns of first should be equal to rows of second.
Right. So if they are not same, we cannot do matrix multiplication. Right. So this is all about, you can say, one of the prerequisites that we can say when we have to go for the matrix multiplications. So similarly, when we talk about vectors, so you can say in your, I think in the 12th class, you studied about vectors. Yes.
Yes,
So yeah, so in the 12th class you studied about vectors. So vectors have different representations as they are seen from the different perspectives. Like if the physics people are from the physics stream, they represent that in the form of an arrow, and the length of the vector, you can say they just represent that in the form of the magnitude and the direction. But here, when we are talking about being a computer scientist and we are dealing with the data, so we see that particular vector in the form of a set of numbers. So you can say the array of numbers is also a vector. So you're just saying it is one row with multiple columns. And if you are showing it with, you can say the column matrix. So here you can say we have one column and four, according to this example, we have 4 rows. So we can represent that in any of the ways. And the size of the vector, you can say it is the number of elements which are there in this vector. And 2 vectors are equal only when all the elements of both the vectors are equal. Otherwise, they will not be considered as the equal vector. So each corresponding element has to be equal. So if we consider the various applications, like I discussed in the last class also. So if we have to represent one image, so in the image, we know the computer does not understand the image, it understands the image in the form of pixels. So each pixel is represented using the 3 colors. So that means we have one vector which has 3 dimensions, and 3 dimensions means first dimension is red color, another is green color, another is blue color. So all these 3 are the attributes or the dimensions or the number of elements which are there in the vector. So similarly, so for based on the various values assigned to these 3 parameters, you can say, or these 3 dimensions, we are able to get the different colors of the pixels, on the basis of which your computers, you can say your algorithms, they try to distinguish one image from the another, or try to cluster the similar kinds of images with each other. So they work on the pixels. So we are representing that image in the form of a vector. So if we have a you can say the size of image 24 by 24, let us say the smallest one, what will be the size of the vector? Yes, what will be the size of a vector for the image of size 24 by 24? Anyone? Any guesses? Yes? Are you there in the class?
1728.
So 1728, how you can just, you no need to, give me the exact value, you can just tell me the multiples. So it will be 24 by 24.
And 24 into 24 into 3.
Right, correct. So this is the size of the vector when we are talking about colored images, isn't it? So if it is black and white, it will be only 24 by 24, that will be the size of the vector, right? So when you work with the in the deep learning, you are working with a CNN algorithm, right? So there, you can say for the image classification, we are representing these vectors, and then we are trying to reduce the size of the vectors through the convolutional layer so that we are able to reduce the complexity of the task. Similarly, in a dictionary, as in the last class also we discussed this example. So using a histogram, we can define the number of words that appear. So the frequency of each word. So where do we use this word count histogram? What kind of applications we use? See, we word count, the frequency count we use in the document clustering or document classification. For document clustering, you can say we find out the similar kind of documents, on the basis of which, see, what do? We take up, let's say we have 5 documents. In each document, we find out the keywords, and then we compare those keywords, whether they, so if we assign the binary values in document 1, that 10 keywords, they are there or not. If it exists in the particular document, we say 1. If it is not there, we say it is 0. So on the basis of these similarities, so we can find out the similar kind of documents, and we can put them into clusters. And in case of document classification, what do? The similar kind of process. So when we classify a document to be belonging to a particular category, if it has high frequency of a particular category of keywords. So we keep a record of the number of keywords. The you can say this you can say for finding out whether this, see, when you search for the search for any kind of documents on the internet, Google search, you write a query and you are getting the web pages, the links to the web pages, we call them as documents also. So the links to the web pages you are getting, they are based on the high frequency. Let's say you want to find out the machine learning books. So all those pages which are having the high frequency of machine learning in the web pages, and along with that, you can say the various other algorithms, the ranking algorithms are being applied, which help us in deciding you can say that which all pages will be shown as the top 10 pages, or the highest ranked page are shown first. So there also these keyword counts, they are playing a very critical role. And again, the data is represented in the form of vectors only. So another example, like a simple example of a document that I have just discussed. So here we have identified the covariance, the bold ones, these covariance, relationships, dimensions, high dimensional data. So all these have been identified as the keywords. And then we can find out, similarly, if we have more documents, in each document we can count, see the count and write in front of it that what is the count of these words in a particular document. So this is how you can say, and then you can say again the data is represented in the form of a matrix or in the form of vectors, depending upon the various features or the attributes that we have. So we did this example that how do we represent the various data points in the grid. So these data points, like when we are plotting the data, so whatever data you have got, when we plot that particular data, we have to represent only the, in the matrix form, only the data that exists. We don't represent the complete grid, and we need not mention the zeros anywhere. So we are talking about working only on the data that exists with us. So we take up the data in the form of a matrix of size 4 by 2. So here you see, when we are talking about machine learning, the various linear algebra concepts which are used for the various kinds of machine learning algorithms. So your vector calculus and your linear algebra, they are used in regression algorithms. Then you have probability and distributions, then analytical geometry. They are most commonly used in dimension reduction or density estimation. Then you have optimization and matrix decomposition. They are used in the classification of the data. And besides this, what is written over here, I'll keep on with every topic we do. I'll keep on taking one machine learning application where you are applying the concept that that you learn in the maths. So now these are the concepts that you already know very, but we just have to revise. So the addition of two vectors, we know when we add two matrices or we add two vectors, the corresponding elements of the two vectors are added. So we after the addition, we get the new vector with the same size only. So and then another is when we say, you can say the scalar multiplication. When we see, if we take if we represent these vectors in the form of you can say the arrows, so the size of those vectors will be increased in the same direction, does not change, but only the, you can say, the magnitude is changing. So similarly for the scalar multiplication also, only the magnitude increases, the direction does not change for that particular vector. So when we multiply this with any scalar value like 3 multiplied by we are multiplying with a vector of 2 rows and 1 column, you can say. So we get the value of 3 by 3 and 6. So only the magnitude is increasing when we are multiplying with any scalar number. Then we talk about norms. Norms play a very important role when we are talking about when we are applying the machine learning algorithms. So norm is basically a function which measures the magnitude of a vector and how to and it is represented using the, you can see, any variable with the double vertical lines. So it denotes the norm of a vector. So we can compute the norm of a vector using the formula square root of u1 square, u2 square up to n square if you have n elements in that. And norm of a vector, here you can see in the diagram that if we have two vectors u1 and u2, so the distance of the vector, these vectors from the origin, it is measured as the norm of this particular vector, and we compute that using square root of u1 square plus u2 square. So taking this example, if the values of these two variables are u1 and u2 are given as 3 and 4, so we take up this value and we are able to find the norm of this vector as 5. And when we study these norms, we study these norms as the distance matrices in the data mining and the machine learning. So you will find these distance matrices in the your data mining books also, and you will find them in the machine learning books also. So Minkowski distance is the generalized distance matrix, and it is used to calculate the distance between 2 points in different ways. So this is a generic formula where we take the summation of I is equal to 1 to n, where n is the number of elements in the vector, and p basically it represents. So based on the value of p, your norms they change. So if we have a value of p is equal to 1, we call it as Manhattan distance matrix in machine learning and data mining, and we call it as L1 norm in the mathematics. Then p is equal to 2, we call it as Euclidean distance in machine learning and data mining, and we call it as L2 norm in the mathematics. And if we want to take the max, that is p is equal to infinity, we call it as the Chebyshev distance. So I'll be taking certain examples and how do we work with it. So the same thing is represented over here when we talk about the vector norms. So L1 norm, we call it as a Manhattan distance, and it is calculated as the sum of the absolute values of the vector. Here you see, if we take p is equal to 1, so your value of p, it gives you p is equal to 1, which simply give you the formula of summation I is equal to 1 to n xi minus yi. So if we take it, p is equal to 2. So here it becomes the L2 norm or the Euclidean distance, and we calculate this L2 norm over here. Distance between x and y is equal to under root of 4 square plus 3 square is equal to 5. But when we take L1 norm, that is Manhattan distance, it is equal to 4 plus 3 is equal to. So we are trying to find the distance between these, you can say, two vectors. So the elements of the two vectors. So here we can say it is equal. So if we want to find out the L infinity, that is called as the max norm. It is the maximum of this. So given the two values 3 and 4, the maximum of these three is 4. So this is how we compute the L1 norm, L2 norm, and there is a correspondence between L1 norm. L1 norm is known as the Manhattan distance, and L2 norm is known as the Euclidean distance in machine learning and data mining. So these are the two popular norms that are used everywhere for the various kinds of applications. So if we take up the numeric point, the two data points of a straight line, you can say distance between the 2 points. So we represent that as under root of, so if we have just two data points in the form of a vector, so we can compute simply taking the values and then take the square root of that. And if we have the data points in this form for the different dimensions we have, so in that case we have to take the difference of the 2 points, the p minus q. So correspondingly the data points are subtracted. You can say the x1 minus x2 whole square and plus y2 minus y1 whole square. Similarly, if you have you can say z1 minus z2, then p1 minus p2. So depending upon let's say if we talk about the same example, we had the flower example that we had four attributes over there, four dimensions: sepal length, sepal width, petal length, and petal width. Now these are the, you can say, a b c d, we have the four dimensions. So four data points that we can say they are in the plane. So we have to take between the two flowers, we will compute the difference between all the four: a1 minus a2, b1 minus b2, c1 minus c2, and d1 minus d2. So this is how we compute the Euclidean distance. And in 2D space, here we can say, and we have to, if we have to compute the Euclidean distance in the ND space, so we have we can have n number of parameters. So a value of n, it varies according to the data set you have. In the flowers data set, we had value of n is equal to 4. In any of the data sets that you take up for your projects, the value of n is equal to the number of attributes or the number of dimensions. It may vary from 1 to n, any value of n. Then we take up similarly when we have to measure the Manhattan distance between the points. So we take up like this. So here we just take the summation and take the difference and the summation, because the value of P, as we have seen in the Minkowski formula, value of P is equal to 1. So we will be just taking the difference. We are not taking neither taking the square of that, nor taking the under root of that. So we will be simply taking the difference of that. Now we'll see the applications of these L1 and L2 norms in the real world when we go for using the machine learning algorithms. So let's say we go for learning the clustering algorithms, that is k-means clustering, and what we have is you have downloaded the movie rating data. So here you can say we have a data of the movies where the rating is given between 1 to 7, and one side we have the users 1 to 7, you can say. So users, so you can say let us say 7 of us has given the rating for the movies, 2 movies, although in the real world the movie rating data we have, if you download the movie rating data, you will have 1000, I think 900 attributes, 900 movies have been rated, and by you can say more than millions of users have rated that particular data. But here, for the sake of understanding, so we should know how the things have been applied and how do we use them. So here we see I have given you one example. So when we apply the k-means clustering algorithm, in that case, in the k-means means we take the average, and k is the number of clusters. Let's say the value of k is equal to 2 over here. So when we take up the value of, so that means we want to create 2 clusters. So initially we don't have any means. So what do we do? From the given data set, we randomly choose 2 users data as the means. So let us say here I have taken the cluster, the mean of one cluster as the user 1, and the mean of second cluster as the user 4. So now what we have, the initial mean vector centroid is 1 1 1 and 5 7. Now what is my task is, now I have to assign all the users, that is 2 3 5 6 7, to these clusters. Now how do we do that? So we can do that either using the Euclidean distance, or we can use using the Manhattan distance. See what I have shown you the first example. If we take the want to compute the Euclidean distance d of movie 2 with centroid 1, right? Yes, this is the user 2. Sorry, this is the user 2. By mistake it is written. I'll correct it. A user 2 with centroid 1. So when we take the 2, so that means this is 1.5 and this is the first dimension, we have to take the difference. 1.5, or either you write 1 minus 1.5 or 1.5, because in the here it's going to, in Euclidean distance it will be squared, and in the Manhattan distance we take the absolute values, so the distance is not negative over here. So whether you write this C1 values minus this or the reverse, it's going to give us the absolute values. So I have written 1 minus 1.5 plus 1 minus 2, taken this value of the y dimension. So you can say this is x1, this is y1, and this is the x2, this is y2. So x1 minus x2 and y1 minus y2, I have taken a square of this and square of this, and after that we take the square root of this. So when we take the, this is 0.5, this is 1. So when I take a square, it becomes 0.25, and the other one becomes 1. When I take a square root of this, it becomes 1.1. Similarly, when I do it with the when I compute the distance of user 2 from the centroid to cluster 2, so I take the square root of 1 minus 5, then square of 1 minus 7, it becomes 16 plus 36, and the square root of this is 7.2. Now, right now I told you that in the last class also, that you have to bring your notebooks. So you start now, you have to allot all the users to these clusters. I have shown one example for you, and now you tell me how many, who all users will belong to cluster 1 and who all users will belong to cluster 2. Start doing it. So here you can say, you can see the various two clusters that we have created, and finally you can see the users 1, 2, 3, and they are in cluster 1, and the users 4, 5, 6, and 7, they are in cluster 2. So I think most of you have done this thing like this only. Once the users have been allotted, so after the second step, see, after in the first step we have the mean vector as the first user and the fourth user only. But as soon as the other users get into that cluster, we have to recompute the mean. Recompute the mean for the two users which are there. And this is how we compute the mean for the users, like 1 plus 1.5 divided by 2, the corresponding values of the two data elements in the vector that we have. So here we know the your first user had 1 value, and the second user which has been allotted, its values are 1.2 and 1.5. So we have computed the values like that. Its values we can see over here. They are there in the data set. Second one is having 1.5 and 2.0. So we compute the mean of these two, and we compute the mean of these two, and this mean becomes the new mean for the cluster 1. So the complete your clustering k-means clustering algorithm, it works like this. Okay, so you can say this is the application. Now this is an assignment for you. So what you have to do is, for the same data set, you have to do the apply the L1 norm, that is Manhattan distance, and you have to show me that. Okay, for the same data set, for the same movie rating data, now you have to apply the L1 norm, and you have to create the clusters, and you have to show me that what are the users which are allotted to cluster 1 and who all users belong to cluster 2. And now you know the whole process. You have to finish it and show me.